Okay, second sheet, changing forms. So in this case, we've got two objects in parametric form. Again, very similar to the homework that you guys did. Object 1 is given as x equals negative 6t plus 9. Y is given as 2t plus 1 for the first object. Object 2, x is equivalent to 4t minus 3, and y equals 2t. We want to determine each object's initial location when t equals 0, and then graph these points and plot these paths. I'm sure you guys can see the color palette at the bottom, so you probably realize that I'm using an iPad to do this, but I'm going to leave this one up there because I'm going to need to switch colors frequently, and I may very well make some mistakes, so I need to use the eraser as we go through, just because I'm trying to graph some things here. Okay, so let's go ahead and determine the initial position for each one of the objects. The initial position is when t equals 0. So if I plug t equals 0 into the first object, t equals 0 basically eliminates those, and that would give me x equals 9 and y equals 1. Now I don't want to completely get rid of that because I'll need it, but x equals 9, y equals 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We actually do have enough space for this. So x equals 9, y equals 1 is right there, if I counted that correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, I did. The initial, so we're going to mark this in green. The initial position of object number 2, which we'll do in blue, is if I eliminate the t parts, because again, that part right there is going to be 0. It looks like I'm going to have x is negative 3 and y is nothing, so y is 0. So we'll have negative 3, 0. 1, 2, 3, negative 3. Oops, that was an eraser. Negative 3, 0 is right about there. That is the initial position of each one of the objects. All right. Then the first part says use the graph. Determine each initial condition, graph these points, and plot these paths. Okay, we have to plot the paths. So the green line is going to change. Let's see, x changes by negative 6 while y changes by 2. So every 6 to the left for x, y is going to go up by 2. So 1, 2, 3, 4, 5, 6, up 2 should put me right about there for the green one. I'm going to keep doing that. 1, 2, 3, 4, 5, 6, up 2 for the green one. Let's see if I can go one more. 1, 2, 3, 4, 5, 6, up 2. I can. And there's my linear path. Good luck in my drawing a straight line here, but we're going to try. It wasn't horrible, but it wasn't great. Alright, and this is moving in this direction. Alright, the blue one. Let's see, y is changing by 2 while x is changing by 4. So for every 4 to the right, it's going to go up 2. 1, 2, 3, 4, up 2. 1, 2, 3, 4, up 2. 1, 2, 3, 1, 2, 3, 4, up 2. So again, that looks like the path of the blue one, and it is moving this direction. So it clearly looks like these things cross paths. Alright, so let's see. Using the graph, write y equals mx plus b equation for object number 1. That was the green one. Well, I can just look at the graph. Now remember, when we write this, while the object itself is moving to the left, we always read a graph from left to right. So when we pick one of these points, if I were to read this graph, I would go, let's see, for my slope, if I was just using the graph itself, I would go down 2 and then right 6. So my slope of this thing, my m, down 2 and right 6 is going to be negative 2 over 6, which reduces to negative 1/3. So y equals mx plus b. Let's see. It looks like my y-intercept here might be at 1, 2, 3. It might be at 4, but I should probably plug these things in just to make sure. I'm given a point. I know my initial point for sure was the point 9, 1. So that means that y equals 1. Here's m. X was 9. plus b. So that's going to be 1 equals negative 1/3 times 9 is negative 3. So 1 equals negative 3 plus b. So b then does equal 4 when you add 3 to both sides. So we are going to get y equals negative 1/3 x plus 4. All right, that's the green one. So I was actually right. My line is better than I thought it was. I actually crossed the right place. The blue one does not look quite as easy. It looks like it might be at like 1.5 or 3/2 or something really close to that. Well, let's find out. So the initial point was negative 3, 0. And it looks like my slope would be up to right 4, which is 1/2 when it's 2 over 4. So let's go ahead and plug this stuff in just to make sure. Y, which is 0, equals m times x, which was negative 3, plus b. 1/2 times negative 3 is negative 3/2. So b then does equal 3/2. So y is going to be 1/2 x plus 3/2. Okay, that's the equation of the blue line. Do the paths cross? They clearly cross. And it certainly would appear that these things cross at, what is that, 1, 2, 3, 1, 2, at 3, 3. We can verify that. We know how to find out where two lines intersect by setting the two lines equal to each other and finding the intersection. So let's go ahead and do that. Let's see. The first one is negative 1/3 x plus 4 equals, the second one is 1/2 x plus 3/2. Now, personally, I would prefer not to work with all the fractions, even though I am pretty good at it. I would still prefer not to. The easiest way to get rid of all the fractions all at one time is to simply multiply every single piece, left and right side, by whatever the common denominator is. Well, I've got 3's and 2's in my denominator, so looks like my least common denominator would be 6. So if I multiply every piece by 6, let's see, the first piece is negative 1/3 x times 6. That's going to be negative 6 over 3, which is negative 2x, plus 24. 1/2 x times 6, half of 6 is 3, so that's 3x. And then 3/2 times 6 is 3 times 6, which is 18, divided by 2 is 9. This is going to be a little bit easier to solve, I believe. Adding 2x to both sides is going to give us 24 equals 5x plus 9. And then subtracting 9 on both sides will give you 15 equals 5x. So x equals 3. This is pretty much what we thought. Then you can plug 3 back into either one of the two y equations. And when you do, just to save a little room, we are definitely going to get y equals 3. Now you can go ahead and plug that back in to check that out. So they do, the paths themselves cross at 3, 3. Will the objects collide is really going to be dependent upon, are they going to be there at the same time? Well, if you do it by the graph, you should be able to tell that this is not the case, because when we did our graph, this was time t equals 0, this was time t equals 1, this was time t equals 2. When you look at the green one, this was time t equals 0. This one, where they actually meet, is time t equals 2. So on the green line, it's t equals 2. On the blue line, it's between 1 and 2 somewhere. So they will not actually collide. And you can see that graphically. No collision. Now, at the bottom here, it says we want to prove that our equations are actually correct, which means the equations that we got here and here. And again, there are other ways to have determined whether these things collide. We could have gone all the way back up to the top here, set the two x's equal to each other, find out the time that the x paths cross, and then whatever time you get, plug it into here. But you should also be able to kind of look at the y equals equations. This is y equals 2t. This is y equals 2t plus 1. Those y values are actually completely parallel. They should never touch. So the y should actually never cross at all. But anyway, there's several other ways you could go about doing that. All right, we are going to now mathematically prove that the equations that we got are correct. So here's how we do that. This is what is called eliminating the parameter. We're actually going to take one of the equations and we're going to solve one of the equations for t. So in this first set of equations here, it doesn't really matter which one, but I'm going to take and I'm going to solve that equation right there for t, which you guys did in the drill. If I want to solve that for t, so let's see, I'm going to subtract 9 on both sides. And then I'm going to divide both sides by -6. So I'm going to get that t is equal to x minus 9 over -6. And then what I'm going to do is I'm going to take all of this and plug it into the t in the other equation. And what I will have done is I will have gotten rid of the t's completely and put it into nothing but y's and x's. It's called eliminating the parameter. So let's see what we get. Y equals 2 times, now I'm going to plug in the t value, which is x minus 9 over -6, and don't forget to add 1. Alright, so let's simplify. 2 over -6 is going to simplify. That's going to be 1. That'll be -3. So I get y equals x minus 9 over -3 plus 1. The -3 can be, the numerator can be split over the -3. So x over -3 is the same thing as -1/3 x, and then -9 divided by -3 is plus 3, and don't forget the plus 1, which does simplify to -1/3 x plus 4. This is exactly what we got up here. So those things are the same. And then you'll find that doing the x and the y for this for the second one is exactly the same idea. So let's go ahead and I'm going to change colors for this just because I feel like it. So it doesn't really matter which one you solve for, although it looks like, again, solving the top one for x seems to be probably like it would be the easiest, because then I'm just going to plug it into the second one and just have to distribute a 2 through. So let's see, we'll add 3 to both sides on the top one, and then divide the whole thing by 4. So t is going to be equivalent to x plus 3 over 4. Now I'm going to substitute all of this into the t right there. So y is going to be 2 times x plus 3 over 4. The 2 becomes a 1 and the 4 becomes a 2. So then this is going to be y equals x plus 3 over 2. And once again, I can split the numerators over the 2. So that's going to become x over 2, which is the same as 1/2 x, and then plus 3 over 2, which is just 3/2. So that is exactly the same. This is called eliminating the parameter, and I will tell you that when you guys get to higher levels, this is the way you are going to want to go about, for the most part anyway. It's the way you're going to want to go about algebraically removing a parameter. Alright, there you go. That is our changing forms. You should have everything that you guys need now, hopefully, to do the homework. And again, if you have questions about the homework from the previous night, I will have a video that very much like these posted, and you will be able to get to that link from your Google Classroom.